Okay. Hello, everybody. Hello. Apologies for the delay. Everything broke. You might have noticed like the course website broke and my tablet broke and the Chromecast broke. And basically, everything is broken, but that's okay. We have lectures sort of working. I totally forgot to do that thing. Can you... make a link under lectures with a link to my slides for today? Yes. The same as the whatever. Okay. So, if and when the course website loads, okay, course website, you can do it. Okay, let's try that again for the second time. Hello. If you can't find a seat, there are a couple of seats up the front, and if you really can't find a seat, you have to leave. I'm sorry, but there are some seats around here. So, shh. Okay, let's try this again. Hello, everybody. Apologies again for things breaking. In a moment or 10, I'll have the link to the draft of my slides up. I'll just let that keep going. The idea being that I won't put up my final slides because I always have more content on the slides than I intend to go through, and I don't want to have like things that you think, oh, I should have seen this in the slides, oh, I didn't, or if there are mistakes that get fixed, or so on. But you'll be able to scroll through it here. Yeah, when it's loaded now. So you can see all of the content. Okay. So yes, welcome to lecture number 4, counting from 0. As for why, you'll find that out soon enough. This week we'll be looking at more on functions, and we're looking at something cool that's new and cool called loops. And so, before we begin, I hope you met some new friends. Again, apologies for everything breaking. So, shh. Here's the summary for today's lecture. So, we're going to be looking at handling invalid input to your program, right? So when someone types in a word when you want a number, how to deal with that, what to do. Looking more at why we use functions, because that's not just knowing how to use them, but knowing why we use them. And then understanding the basics of while loops, which we'll look at the end. I'm talking really fast, aren't I? Talk slowly, sign. And again, you shouldn't be able to do these by the end, but this is the skills you need to learn how to do these things. Okay, don't panic. I'm a little bit panicked because I've just been running around and everything's been broken and it's stressful, so I too will not panic. It's week 3. So for many of you, you've survived your 2 weeks, your first 2 weeks at uni ever. Has that been good? People have just started uni. Have your first 2 weeks been pretty good? Pretty terrible? Can I speak closer to the microphone? I can certainly try. Is that any better? Sort of? Okay, is that better? Is that more audible? Shh. Okay, is this a better volume? Cool. So week 3, first 2 weeks of uni survived. Hopefully it's been a good first 2 weeks. Uni is fun. I like uni. You like uni. I hope everything's good. Same as last time, lecture recordings on the course website. Has anybody not yet written a program from their home computer, like hasn't used VLab or anything like that at all? Cool, so either you aren't here or you've all managed to do it, so that's good. And uni emails, very important. How many of you got an email from me earlier saying the course website was broken? How many of you didn't get an email from me saying the course website was broken? You guys need to make sure your emails are set up right. Okay, so one thing, a couple of people have requested like some challenges to work on during the lectures, and so I've got a challenge here. I'll sort of give different versions throughout the lecture. If you're finding things hard and confusing in the course, don't worry about these. Like this is sort of a challenging thing for people who are sitting here bored. So if you're sitting here bored being like, oh man, I know this stuff, do something new, hopefully these challenges will be interesting for you. And again, these slides are on the course website, but I'll go over it briefly. So a fun game is guess the number. So like the computer's thinking of a number, the person enters a guess, then the computer responds higher, lower, or correct. So let's do this. I'm thinking of a number. Someone guess a number. Someone said 21. It's higher than 21. It's lower than 50. It's 2 guesses. Someone said 42. Yes, that was the number I was thinking of. So you got that in three guesses. If you're bored and want a challenge, try writing this program and think about like what's the minimum number of guesses you need to do. There are the hints. And then later on, there'll be a more fun, harder version of this challenge. Okay, so hopefully you all remember functions. They're building blocks in our program, right? We can have a program that's just a long main function, or we can have little functions that we use together as building blocks to make up our program. The idea being that they're self-contained and reusable pieces of code, so a function should do just one thing, and it should do that thing really well. And we use them for abstraction. And just a review of the terminology, I guess. Functions have a return type, so the type of thing that they give out. They have the parameters they take in, so like a toaster, for example, takes bread, gives out toast. So the layout return type, function name, function parameters, the statement, so like the content of the function, and then at the very end, the return statement. Cool, and like I said, we can use them as building blocks, right? So, for example, we could write a function that takes a number and multiplies it by 2. So we put in the number, we give it the 5. We put into the function, we get it out doubled, it's 10. So again, the input, the output, and the function, apologies, the functions won't change the values. So when we call doubled x here, x doesn't change, so we have to update it like this. So hopefully you roughly remember those things. We're going to look more at why we use functions, like what the point of using functions is. So, full screen. Let's take the code from last week and make it be more better using functions. So we looked last week at the logic side of things. So we got a speed that someone's driving at, and we went, is it faster than the speed limit based on the license type you have? And so I don't think we looked at the input sort of things very much. So I'll look at that really quickly. We have a license and a speed. So the type of license you have, the speed you were going at, and the speed limit. We print out and say, okay, what speed were you going? Then we scan in the speed that they said they were going at. We print out what license type do you have, the choices being learner's license, P1, P2, or full. We scan in a license type there, and then we can compare these variables here. So if the speed is more than the speed limit, if the license is equal to the P2 license. So we talked briefly about hash defines last week, which are these things up here. So it's a way of taking a number that's sort of meaningless and giving it a name that is meaningful. So in this case, the license type that you can enter 0, 1, 2, or 3. Like, what does license type 1 mean? That's completely meaningless. There's no such thing as license type 1. So they're just arbitrary numbers that we've glued to like mean something. So in this case, when they enter the number 1, we can refer to that as P1 license. And so then there is our logic from last time. Is this all good so far? Cool, I got a thumbs up, thank you. So when you forget to run it in the background with the ampersand, you can type Control-Z and then BG. Okay, compiling. License.c. It compiles. So let's make sure it works. What speed were you going? Someone, talk slowly. Someone pick a speed. 80, 70, 80. What license type do you have? Choices, learners, P1, P2, or full? P1, cool. So to enter P1, we're going to type the number 1. And then it goes, I should get rid of the A. It goes, you are not arrested. So if we run it again, let's say you're going at 100 and you had a learner's license. Of course, 100 is faster than you're allowed to go, so it prints out arrested. let me delete that A. I didn't save it. Cool. 100 letters arrested. Okay, and so this is probably what the programs that you've written so far look like. You have a main function and that does everything, right? So here is what your program does. It sets up these things, gets these variables, scans in this stuff, does this whole thing of logic here, then returns at the end. So this is sort of like your whole program is just this one big chunk. It's all in one function, and all of the details of how everything works are all in this one place. But my view on how functions should look, on how programs should look, is the main function should just be telling you this is what the function does, this is what the program does. And so in an ideal world, for me, the way I want my main function to look like, there would be like 4 or 5 lines. The first line would be get the speed, get the license type, if they're going too fast, print arrested, else print not arrested. Right, and so this is the core logic of our program, right? You agree that this is what the program does. So we can see getting the speed and license type is this block of printf and scanf. If they're going too fast, print arrested or not arrested is this whole block of logic here. But what if our main function could literally just look like this? Wouldn't that be amazing? I think it'd be amazing. Let's make a new function, a new main function. What do you think happens if I have 2 main functions in my program? Any ideas? Can you have 2 main functions? No, you can't, because like the main function is the one that happens. Yeah. Error, you have too many main functions. But I'll temporarily call this one not main. So in my main function, I want it to look like this, right? I want this to be what my program looks like. So I want to start out by getting the speed, getting the license type. If they're going too fast, print arrested, otherwise don't print arrested. So cool. And I can use a function for this. So I'll work out what I want to do now, and then I'll work out the details of how to do it later on. So in order to get their speed, I want a function called getSpeed, and this will handle all of the details on how to actually get their speed. All I need to know is that this function says it will do this, and it'll give me back the number of the speed that they were going at. And then getting the license type. Again, what could I do here? Yeah, I could make a function called getLicense. Oops, getLicense, I'll say license type. And again, these functions don't exist yet, but I'm going to make them later on. I'm going to work out what I want to do here at a higher level, and then work out the details later on. If they're going too fast, so how can I check if they're going too fast? I can have a function, right? Like if going too fast, print not arrested. And else print not arrested. Okay, so does this code look like sort of the absolute minimum code that we can have to do these things here that I've said I want to do? Yeah, and so I can delete these comments now. This comment is now redundant. It says this line gets the speed, and this calls the function getSpeed. A brief side note on comments. It's something I've seen in my tute. I have my tute on Mondays. Some of you are lucky enough to have me as a tutor. I'm sorry. I hope you don't mind. Lecturer and tutor. But something I've seen is people, the type of comments you write. And the idea behind a comment is that it should describe why you're doing something, not what you're doing. So for example, I might say if A is less than B, right? A bad comment here would be check if A is less than B. Like, this comment is redundant because we know that that's what this line is doing. A better comment depends on what we're actually using this for. Might be something like find the smallest value or something. Just a thought. But looking back at this, get speed, gets license type. If they're going too fast, print arrested. Otherwise, print not arrested. Cool. So let's look at this one here. I said if going too fast, calling a function, and then some question marks in here. When I call a function, what should go inside those brackets where the question marks are? Give you a clue, it's a word, and it starts with P. Parameters, yeah. So the function parameters go in here, which is the inputs we give to our function. And so if we have a function that works out if we're going too fast, what does this function need to know? Yeah, the speed and license type. If we can say, hey, this is the speed that we're going at, this is their license type, can you tell me if they were going too fast? And we can literally do that by going license. So this part here, this bit here that's highlighted, is now doing, it's saying I'm going to call a function called going too fast. I'm going to give it the speed and the license, which are these ints up here. And then it's going to give me back a return value of some kind. And if that return value is true, like here if I said, you know, if I equals 5 and I is 5, then it'll be true. If this is true, then print out arrested, otherwise print not arrested. Looking at this main function here, can you tell me what the program does? I mean, we've just talked about it, but if you hadn't just talked about it. Is this like straightforward, you read, sort of get speed, get license type if they're going too fast, arrested or not arrested? Who thinks that this is like nice and readable now and easy to understand? And if you compare it to this one here we had before, like why, well, first of all, do you think that this one here is nicer than this one here? Why is it nicer? Like, yeah, it's simpler. Like, why is simple a good thing in this case? Why is simple good? To me, like, I would say it's less messy. Because I look at this, and you can sort of read each line, okay, we do this, we get the speed, we ask what license type, we check if this or this or this, but you need to keep a lot of state in your mind. You need to remember what's going on, all the little details for all of the things, before you can see what it's actually doing overall. Whereas this way, like, to me, you just read this, and it's just like a book, get the speed, okay, gets the speed, get the license type, gets the license type. All of the details on how things are being done are somewhere else. We just know what's being done in the main function. I think this is really cool. This is one of the things I love about functions, programming, all of those things. But of course, we can't just magically have the functions we want exist. That'd be really nice, just, you know, call a function that magically exists to do everything you need. So instead, we must write these functions ourselves. So I'll start out with getSpeed. Remember, functions have a return type, a name, input, parameters. So for my getSpeed function, the name is getSpeed. What is it going to return? What type is it going to give me back out? An int, yep, a number. Cool. And what input is it going to take? What does it need to take from the main function? So getSpeed doesn't take the speed because getSpeed is the one that gives us the speed, right? And so if you remember before, we did like a printf, what speed are you going, scanf back in. So getSpeed doesn't need to take any input. It'll handle all of the scanf stuff for us inside there and then give us the answer back. And so, hey, conveniently, let's just steal this code from before. So the getSpeed function will printf, what speed are you going, scanf into a variable called speed, so I've got to make a variable called speed. Speed. And then it'll give this back. So what this is doing here, it's saying, make me a variable called speed, to put the speed in for now. Print out, scan in the number, and then return the number back. And so this is a little self-contained blob. All this function does is prints out what speed are you going, gets the speed, and then gives that back. And that's all we needed to do here, right? So this function does exactly one thing, gets the speed. And then getting the license type. What is this going to return and what's its parameters going to be? Same as before. And get license type void. And again, let's just grab this. Check in here. So again, I need to make a variable to hold this result in when I scan it in, and then return it at the end. So otherwise, this is the same code from the main function before, but it's all like encapsulated. It's all like contained in this one little function. Cool. And so now these bits of our code will work. We've just got to do this bit now, the going too fast function. So looking at this, what type is this going to return? This is a bit of a tricky question. What answer do we want it to give us? Yeah, true or false, right? We want to know, yes, they're going too fast, no, they're not going too fast. It turns out there's no way in C to have like a true or false variable. So we just have an int. We just return an int, and then we know that if the int is, for example, 1, that's true, 0, it's false. When I take in my parameters here, what do I need other than their names? Yeah, the types. Oops. Int speed, license. And so this whole blob here together now means I've made a function called going too fast, takes in two numbers, speed and license, returns an int of some kind. Okay, so something worth noting here, in this function here, it gets given these variables. So like, this is effectively the same as if we went in speed equals something and license equals something. So this part here is effectively the same as this code here happening and being given values in here. So we get two variables, int and license, sorry, speed and license that we can use in this function. Cool, so let's grab our logic. So you'll see here, this function is doing the printfs, right? So this function, we want it to give us a true or false, going too fast, yes or no. So rather than doing the printfs in here, we want to be doing the printfs in here in the main, and this one just works out the true or false answer for us. And so the way that I do that, rather than printing out here, is I store effectively the answer as I go through. So I start out by making a variable to hold the answer. I then update that when I hit the thing that would say arrested or not arrested, and then I return that at the end. Just call arrested. You know how I talked before about like arbitrary numbers that don't really make any sense? Like what does 0 mean? What does 1 mean? Is it significant that arrested equals 1? Is that really clear that it means you're arrested? Not really? Does anyone want to say, oh, not really? Not really. And so this is an example of like what I'd call magic numbers again, right? These numbers mean nothing. What do we want to know instead? We want to know like true and false, right? We want to be able to return true, yes, they were arrested, or false, no, they weren't arrested. And so I can literally just do those hash defines here. This is like saying whenever you see the word true, it means the number 1. So now I could write those lines like that instead. Cool. So in terms of the logic in here, instead of the printf arrested, I want to write arrested equals true. And this means that when this function is called and goes back to the main function, it says, the thing I'm giving you back is arrested. Yes, they were arrested. That's true. So this will get the true value to it here. So I can literally just copy and paste, replace that one there. So whenever I would print out arrested, I can just set arrested to be true instead. When I print out not arrested, I just set arrested to be false instead. I need to, I can only make it once though, right? Like this is just examples of what it could have been. So I need to declare it. And what should I initialize it with here? Does it matter what I put here? Yes, why does it matter? Say that again. Yeah, I've got two options, true or false. You'll notice that with this if statement, we have if, else if, else if, else if, else, which means that one of these will have to happen. At least one of these will, exactly one of these will have to happen. So that means that I don't have to give it a value to start out with because it'll already have, it'll be filled with one of these values. But I can do a cool thing. Because it doesn't really matter what it starts out with, I'll start it out as false. Right? And so then the logic will go through, if it's more than the speed limit, you're arrested. If your license is blah and your speed is blah, arrested, arrested, arrested. And then at this point here, I know that the person is not arrested because they didn't fit the criteria of they were speeding or they had this license and they were going too fast. And so at this point, I can just do nothing because I've already set it to false up here. So this is sort of like, what do they call it, like proving assumed innocence until proven guilty or something? Like, we start out by saying you're not arrested, and then if for some reason you are arrested, we update to say, yes, you are arrested. And then at the end, we give back this thing here. So does this make sense, why I can just do nothing in this bit here? If you're confused, raise your hand. A couple of you. If you're confused, do you know why you're confused? So the question was like, shouldn't we put something in there or leave a comment or something? I think I heard someone tell you the answer and then you sounded convinced. Yeah, do you want to say that louder? I really didn't hear what you said. Did you say, can the else statement just be removed? Yeah. Yeah. Yeah, so we can just remove this here, right? Because if they get arrested for any reason, it'll happen in these things here. And so if they don't meet any of these conditions, then they don't get arrested, so we can just return false. Shh. Be quiet, please. So does this make sense? I've got the logic here. Instead of the printfs in here, I just have set the arrested value to true or false. So this function here, one little self-contained blob, its job is to tell you if you're going too fast. So here it is, give them the speed and the license type, and it'll say yes or no. And then I think that's everything. So I've got my get speed function, I've got my get license type function. If this is true, if it's going too fast, then it'll print arrested. If it's false, it'll print not arrested. And then it will return 0. Do you think this is going to work? So was the question like here, should it be returning an integer rather than like true and false? So it's returning an integer. The value is either false or true, like the capital letters hash defined value, which means if it's returning false, up here that's hash defined to be 0. So that's like saying it's returning 0, but we're giving it the name false to make it clearer what it means. Does that make sense? Cool, yes. Do we have to declare the functions at the top? Yes, we do. What a good question. So one of the things we need to do, I don't know if I talked about this. I've definitely answered on the forum about this, so I don't know if I did both or just there. When your program is compiled, right, the compiler goes through and it goes, I'm going to compile this, compile this, compile this, compile this, and it turns all the functions into like a piece of compiled code, right? But in order to do that, it needs to know what the functions are. So when it starts compiling main here, it's going to go int speed, cool, make me a number, that's good, equals get speed, and it's going to go, hang on, what? I don't know what get speed is. Like, I don't know if the code's right or not, I don't know what get speed is. And so we need to tell the compiler in advance, hey, get speed is a function, returns an int, and takes in nothing. And so now when it's compiling, it'll get here, it'll go get speed, oh yeah, I know that get speed exists. I don't know how it works yet, but I know that it exists. So then the same for get license type, going too fast. And the way to make a function prototype, you just copy the first line and then chuck a semicolon at the end. Cool. Good point. Are there anything else? Any other things that might need doing? Yes. As in this speed limit here? So that's a good question. Where do we define like the overall speed limit? We don't. Before we were using this variable speed limit here, right? Which we just set in the main function as 130. But it's probably more useful to know the speed limit for the given road they were on, right? So that we can actually check if it's a useful speed limit. And so let's just go, hey, int speed limit. I use camel case, I've used, cool. Equals get speed limit. Cool. And so then my function now needs to know the speed, the license type, and then the speed limit overall. And then with this knowledge here, the speed limit, and I'll chuck that down here. This variable now, it knows what this is now. So what I've done here, I've added the int speed limit to the function definition signature, I think. And now I can just use this variable here in the function. But of course, we have to write the functions we want. So we have to write a get speed limit function. So what do we need to change in here to get the speed limit? We just ask a different question, right? What was the speed limit? Cool, and so now my main function also gets the speed limit, gives that to the going too fast function, and then will print arrested or not arrested. Does this make sense? Do I know how to resize a terminal? Yes. Cool. Are there any questions so far? Okay, who thinks this code is going to work? It is going to work. Who thinks the code will work? Who thinks the code won't work? Who is just confused and doesn't really know whether it'll work or not? Okay, so people who are confused, do you have any things that I can say to unconfuse you? Yes. So go over the what order? Right, yes, okay. So I think your question was like, you've just gone everywhere all over the place. Shh, shh. You've gone all over the place. Can you sort of go through in order? Yes, I can. So running our program from top to bottom then. First we have these things saying, hey, later on you will see these functions. They look like this. Our main function then is doing the thing. So when our program runs, this is what's going to happen in order. So the first thing that's going to happen is it's going to say int speed equals get speed. And so it's going to make a variable in the main function and then call this get speed function. So it's going to jump down here. It's going to start running this code. So in this one, it's going to make a variable speed, print out what speed we're going, scan in the speed, and then return that speed. So now this here is going to have the variable speed that we scanned in down here. Does that make sense so far? Yes, yes, one thumbs up. It's good. And then int license, again, get the license type. So we come down here, we call this function here. It prints out this stuff here, what license type do you have, these are your choices, scans it in, and then returns the license. And so then when the return in the function happens, it goes back to the thing that called it. So like the main function said get license type, then it's done, so now we go back to the main where we were up to. Speed limit, exactly the same. We make an integer to fit it in, call the function get speed limit, which then jumps down here, prints out what's the speed limit, scans in the speed limit, gives it back here. And now that these are all done, it goes to this if statement. So it goes, if you are going too fast, given the speed license and speed limit. So this here, calling a function, it's going to jump down to this function here, and then jump into this code. So it's going to start out by saying you're not arrested. But it's going to say if your speed is more than the speed limit, you are arrested. Otherwise, if your license is this type and your speed is more than it's allowed to be for that type, you're arrested, and so on and so on. And then return back the arrested value. And so then back in our main function, if that returned true, then this will happen. If it returned false, then this will happen. And then return 0 at the end. Does that make more sense now? Cool. Any other questions or anyone else still confused? Yes. So it's fine that they have the same names, do you mean? Yep. So the question was, like, we've got the same name here, like speed limit is called speed limit here, and it's called speed limit. Guys, come on. We'll have a break in a few minutes. We'll get there. It's fine. It'll happen. For now, just, it's like a hot lecture theatre and there's lots of people. I understand it sucks, but bear with me. Is it okay to have the same variable names in different functions? The answer is yes. When we call the main function, like it makes a box called license in the main function. I would draw a picture, but my tablet's just crashed, so I'll get that working in the break maybe. But let's say in our main function, here's our main function. It's got a little box inside for the license variable. In the get license type function, for example, that's over here with its own different memory. So when we do this line here, get the int license, we've made a new little blob, a new place in memory to put the license, the number. But that's sort of separate to the license type function and the main function. So it doesn't matter what the names are in each of the functions. What happens in this function stays in this function, basically. So it doesn't matter what any of this stuff is called. If it's called that in the rest of the program, that's fine. This function here like exists in its own little safe little bubble. Does that make sense? Whoever asked the question. Cool. So having explained those things, do you think this code is going to work? Who thinks this code is not going to work? Why not? Say that again. You don't think I've called that line there? Ah, I haven't made a prototype for get speed limit. Very good, I hadn't noticed that. You're right, it wouldn't work. So again, because I made a function called get speed limit, I need to have another function prototype here. Copy this one here. To tell it, hey, later on, you will see this function appear. I hadn't actually noticed that, so good work. Shall I just run it and see what happens? Yep. License.c compiles. License. Okay, what speed were you going? Anyone? 200? Dude, what are you doing? What license type do you have? Person who's going 200. You have a learner's license? Come on, man. What's the speed limit of the road? Let's say it's 100. You're arrested. You were going 200 with a learner's license on a road that you could go up to 100. Right? So it doesn't even matter if you had a learner's license. You're breaking the speed limit by like double the speed limit. You can't do that. Okay, let's try something else. What speed were you going? Pick a smaller number. 5. What license type do you have? Full license? What was the speed limit of the road? You guys said 2. There's no speed limit of 2. Let's say the speed limit was 100. So if you were driving at 5 with a full license at a road with a 100 speed limit, you're not arrested. Maybe you should be arrested for going too slowly. I think that's also against the road rules. Anyway, does this make sense here? We call our getSpeed function here, and it prints out here what speed we're going, scans on the 5. We call the getLicenseType function, that does the same thing here, and so on. Shh, please be quiet for 2 more minutes. So our main function now, we look at this and we see exactly what the code is doing. We don't actually care how it gets the speed, right? We don't need to see the details of the scanf and the printf because all we need to know is that it gets the speed, right? And so then if we compare this with, oh, I totally should have not deleted all this stuff in here before, whoops. I can grab that back. So if we compare this with No, I don't know where it is. With the old version that you can remember in your minds, this is a lot more readable, right? Do you agree? I hope you agree. So I'll jump back to the slides real quick. I think there was just one other thing, right? So the main function, we want to know what it's doing. We don't need to know how it's doing it, right? That's sort of like the, I don't know, one of the big things in computing. We need to know we want to know what something is doing, but we don't care about how it's happening. The details, we can just sort of gloss over those. So I have one more thing that I can talk about. I can either talk about it now or talk about it after the break. It'll take all of about 5 minutes. Who wants a break now? Who wants a break in 5 minutes? I think break now 1. So let's have a break, timer for 10 minutes. Please stand up and down, like don't just stay sitting there. It's a stuffy lecture room with lots of people. Quiet. So hello again. How many of you have just sat in the same place and not stood up at all during the break? Please stand up now and sit down again, like trust me. It's not fun to just sit the whole time. You fall asleep.
Stand up! Woo! Yeah!
If only I had his energy. Okay, and now pay attention again. Conflicting things. So, hello. If I talk like this, will you be quiet? It sounds really annoying, doesn't it? Okay, so a thing that you have seen in previous weeks, if we do scanf, and we scanf for a number, and we don't type in a number, things go really weird and wrong, right? So wouldn't it be nice if we could like deal with this somehow and know that it's happening and act accordingly? So what do you think happens in this code here if this code runs and they don't type in numbers? Someone said error. My approach is always like run it and see. Let's grab a main function real quick. Void. As you can see, trying to type fast just goes slower. You typed A, B. Cool, so I have this blob of code here. So I have int A and I have int B. I scan in int A and B, I scan in 2 numbers, and then I print out what they typed. So if I type in 5 and 5, you type 5 and 5. What if I type in like no, go away? Like those are not the numbers I typed in, right? Negative this thing and 60. It was 69 last time, wasn't it? Who knows? So this is bad, right? If we were doing some like super critical calculation and for some reason the world depended on this being right and you know it expected like if we type 1 and 2, we get 1 and 2. But we actually didn't type 1 and 2, we typed this and we got this. Like, it could be really bad, right? We need to be able to tell if things have gone wrong and then deal with them accordingly. And so, you remember how with, I should have removed that from this example. So you remember how functions have return values, right? And we've written our own functions like getSpeed returns an int. Turns out scanf also returns an int. What do you think this int is going to be? You think it's going to be 0? Is that because you're just guessing 0 or because... So I'm sure I've said this before. When you don't know what something is, when you have a question, what are the things you can do? You could ask your tutor, you could ask me, you could Google it, or you could try it yourself and see. So in this case, I think it's a try it yourself and see sort of opportunity. Am I talking too fast again? I'm sorry, I'll just put this in front of the code. So compile it and see scanf, type in some stuff that's not numbers. So you can see you typed this, right? And scanf returned a 0. So if I type in 2 actual numbers, scanf returned 2. Okay, what do you think this means? What do you think it'll return if I type in like one number and then one word? 1. Very good. So what is this printing out? Like what does this return value mean then? If it's 0 when we type random stuff, 2 when we type 2 numbers right, and 1 if we type one number right and then a bunch of random stuff. What could this be telling us? Yeah, the number of correct things, like the number of things that we did scan in successfully. So if we know then that this will be 2, this will return 2, this will be 2 if we scanned in 2 numbers, what could we do to deal with the person not typing in 2 numbers? So you could like do if something, then maybe like printf you didn't type valid input. So what could I put in here? Like I want to check if they've typed valid input, and if they haven't put valid input in, print out you didn't type valid input. Yeah, if num equals 2. Someone? Isn't it if it doesn't equal 2? Very good. I'm not sure if I've shown you the not operator yet. We can have, so equals means if num is equal to 2. But if we have exclamation mark equals, that means if it's not equal to 2. And that's just the way that we say not in computing, sort of shouting. So in this case, if num is not 2, print out you didn't type valid input. And then print out scanf's return value, and then you typed this. So hopefully this now means that when we run this program, if we type in like hello world, you didn't type valid input, scanf returns 0, and you typed this stuff here. And if you type in 2 actual numbers, scanf return 2, we didn't say you didn't type valid input. Cool. Does this sort of make sense? We can check what scanf returns, because scanf will return how many things it succeeded at. We can check if that's the number that we want it to be, and if it is, all good, and if it's not, bad. Yes? If I followed the valid input with something invalid, would it still work? So if I did like, once I caught a fish alive, who thinks this is going to work? Who thinks this will still print out, scanf return 2 and then print out some numbers? Who thinks this will say you printed invalid input? Who is just completely confused and has no idea what's going on? The rest of you. So let's try it and see. Scanf return 2, you typed 1, 2. Interesting. It turns out the reason for this is because scanf is just going to scan what you've told it to, and then be done with it and move on with its life. The reason that it doesn't like instantly go, because when scanf is reading, it's reading, okay, 1, 2 are numbers, I'm done with my scanning, I'll just ignore all this stuff. The reason it doesn't automatically happen as soon as you've typed 1 and 2 is because when we're typing things in the terminal, they sort of get saved, and then when you hit enter, they're all given to scanf. So whatever we type after here, nothing's actually gone to scanf yet. We hit enter, scanf has been given this stuff here. It goes, I want a number, and a number. That's a number. That's a number. I'm done. Cool. And then stops looking at the other stuff. Cool. Good question. Person who had that question. Any other questions thus far? Okay. So what about this? See how I've got int num equals scanf, and then if num does not equal 2. Could I avoid having 2 lines? Could I put this on 1 line? Could I put the scanf in the if statement? Should I put the scanf in the if statement? When I'm saying int num equals scanf, that means that num here will be equal to this, right? So I can just replace num with this. comment out that line. So now this is saying if scanf, our two numbers into A and B, does not equal 2, you didn't type valid input. But if we want to print out the return value, we have to keep track of it. Does this error that's just happened make sense to anyone? Because I looked at this and I went, oh, I'm silly, I know what the mistake was. How many people look at this and are like, I don't know what this error means or how to fix my code? Really, only like 3 of you. The rest of you maybe aren't paying enough attention to the strange error message. There's a saying here, use of undeclared identifier num. What that translates to is, I don't know what num is. It explains down here, like if you mean to use as a variable, make sure you've declared it, blah, blah, blah. The reason it doesn't work is because num isn't anything, right? I've commented out the line for num, so it's gone. But if I comment this line out as well, all will be good. GCC, it runs, I hope. Scanf. 1, 2, you typed 1, 2, hello world. You didn't type valid input, and then you typed this stuff here. This is sort of, like, is this redundant? Should we also print out what they typed if it was invalid? Does it make sense? No, it doesn't, because it's invalid input, right? So how could we do something about that? Yeah, I could have an else statement. So else, if it did succeed, then print out this thing here. Cool. 1, 2, 3. Cool. Hopefully that makes sense. Are there any questions so far about this? Yes. Say that again. Do you mean why don't I have this return 0? Because I forgot to type it. That's a very good question. As for why it still works, computers are pretty good at like dealing with things not doing what they should do. I think that even without it, it still does it. I think the program will return 0. It's not guaranteed. Like, there's no rule, as far as I know, tutors are busy, saying that if you don't return 0, it'll return 0, but it didn't break without me doing it. Very good question. Any other questions? Is that a question up the back? Yes? Why does num equal 2? So in this case here, why did num equal 2, do you mean? Yeah, so the reason for this is because num contains the number of things scanf has successfully scanned in. So in the case of this, scanf %d, put it into A, into B. If we type in 2 valid numbers, scanf will return 2 because it got 2 numbers out. If we type in 1 number in 1 word, it'll give us 1. If we type in just random words, it'll give us 0. Cool. Other questions? And I have some slides on this just to prove that it's written down. Oh, that's got a scroll bar. So scanf returns a number of things successfully scanned in. Num will be 2 if they both scanned successfully. And we can wrap that in an if statement as well. So we can just say if scanf blah does not equal 2, invalid input. Cool. All good? I have some more words on functions. I said those last week. So before we get started, how many of you looked at the challenge exercise and tried to do something about the challenge exercise? A couple of you. Did you find it fun? Find it fun? Was it too easy? Too easy? So again, challenge if you're bored. If you're not bored, then don't try and do it. So let's make guess the number version 2. So this time, computer thinks of a number, enter a guess. Program responds high or low or correct, but then asks again and again until you guess correctly. So rather than just guessing once and exiting, the program will ask repeatedly until you found the right answer. Hint, use a loop. What is a loop? Stay tuned. People who did the challenge, are you still bored from this challenge? Do you want another challenge? Anyone? You want another challenge? Okay, so I have the final challenge. I wasn't going to show you at the end, but this is the final challenge. Try turning it around. Have the human think of a number and the computer guess what the number is. Cool. If anyone else is bored and wants a challenge, it's a really fun challenge. But for now, something new. Yeah, we like new things. I'm going to hold up my talk slowly sign. So, remember if statements? If you don't remember if statements, I'm quite concerned. So, the structure is like this, right? If something is true, then do something, otherwise do something else. But what if we wanted to do something more than once? And is that readable? Is that font big enough? Is the font too small, anybody? Cool. So what if we wanted to do something more than once, right? Rather than saying if num is less than 10, we can say while num is less than 10. And like in English, this makes sense, right? If something is this, then do this. That's you do a thing and then you're done. But while something is, while num is less than 10, while this thing is true, keep on doing the thing forever, or until it's no longer true. So let's run this. And by the way, make 3. You can get my code that I've been doing on the course website, and I'm just putting it there now. Lecture 5 star.c. Full screen. Okay, code is now on the course website if you want to find it. So scanf, goodbye scanf, hello loops. What have I completely forgotten to done in all my programs I've written today? Yeah, the comments. So what happens, man, when you're really stressed because everything's gone wrong and you're like, oh, I just want to make my code work, you forget to do the important things. Print out hello multiple times. Andrew Bennett. It also means you get to know what the date is. You type it in all the time. Cool. So here is our function. Hopefully this is straightforward so far. Print out a number, scan out a number. Then this could be like if the number is less than 10. I'll make it be if for now. Print hello, and then return 0. So loops.c. Oh man. What else did I forget that's really important? That bit as well. Cool, so enter a number. 7. Hello. 7 is less than 10, so it's printed out hello. If I enter 12, it's not less than 10, so it doesn't print out hello. Hopefully this is good so far. We've done this a million times. Shh. But if I change it from if to while, this means rather than checking if it's true once, continue doing this thing while num is less than 10. So what do you think this is going to do now? If I type in 12, what's going to happen? Nothing, right? Because num is not less than 12 is not less than 10. What about if I type in 7? It's going to print hello a lot of times. And so you can see what's happening here. While num is less than 10, it's printing out hello. Why is this like a weird thing to do here? Why is this silly? Because num is not changing, right? Either this is always true or never true. So let's just stop that. Just to prove that to you. Num is num. So I've just put it in to print out what num is. If we do 5, num is 5, hello. Cool. So we need to make num change then, right? If we want it to Because a loop is silly if it's always true or never true. Like, you don't want to do something infinitely or never. So what could I do in here to make it not run forever? Yeah, I could increase num by 1. Let's just go even simpler. Num equals 10. Put it out at the end. So in the loop, while num is less than 10, print out num is this, hello, and then set num to be 10. So when I do this, is it going to keep going? No, because 10 is not less than 10, right? So let's run this, oops, type in 5. Num is 5, it prints out hello. So it's done num is 5, print out hello. It's set num to 10. And now it's down here saying num is at the end, this line here, saying it's 10. Cool. So I've effectively just written an if statement, kind of, where it just, at the end I set num to be 10 so that it's no longer true, and it's effectively, it's doing it once. It's, no more fun than an if statement. But someone said, what if I add 1 to num? So in here, num is equal to itself plus 1. So what will happen now? If I enter 5, what's it going to do? How many times is it going to print hello? 5? So num is 5, hello, num is 6, hello, num is 7, hello, num is 8, hello, num is 9, hello. Then at the end, num is 10. I'll shrink that a bit. Oh. You'd think that, I'm a computer scientist. Why can I not resize a window in an editor? These things should not be hard problems. We have designed computers wrong. When you build editors in the future, make them easier to resize. Okay, so running that again, I entered 5, it's printed out. Come on, I just want to view them both. Printf num is, and num is 5, because we scanned in 5, right? Print out hello, and then num equals num plus 1. So num is now 6. 5 plus 1 is 6. Then it comes back again and it checks while num is less than 10. Is 6 less than 10? Yes, it is. So it's going to happen again. Print out num is 6, hello. Num equals num plus 1, so num is now 7. The way our while loop works, if statements just check once and they're done with it, the while loop does all the stuff inside it, so like inside the if statement, but then when it's done, it checks it again at the top. It goes back to the top. And so we'll get to the point where num is 9, print out 9, hello, then it'll say num equals num plus 1, it'll be 10. So then it's going to check it again, while num is less than 10. 10 is not less than 10, so it's going to stop doing it. And then it's going to come down here, printf num is at the end 10. Does this make sense? What questions do you have so far? Someone said something about initializing? Oh, is it why do I not initialize it on line 10? So what I'm doing here, because I'm setting num here, I'm just going, oh, it's fine to not give it a value now. But when could this not be fine? Like if I don't type in a number, I just typed in hello or something that's not a number. Because you know how it was like negative some large number before when I just typed in random stuff? That's happened here. I don't want to wait for this to run forever. Probably not quite forever, a reasonable amount of time. So this is the case where not checking if scanf is succeeded is sort of bad because I'm stuck in this loop for a very long time rather than being in it for a short time like I would expect to do. So I will kill that now. Okay, so another shorthand, I don't know if you've seen, I think it might be in the tute this week. When we write num equals num plus 1, because this is something that we write so frequently, there's like a shorthand for it. So we can just say num plus equals 1. And so we could also do something like, say, num times equals 1. Oh, that's boring. Num times equals 2. So this line here is the same as writing num equals num times 2. This one here is the same as saying num equals num plus 1. But because we add 1 to things so often, there's an even shorter shorthand, which is just num plus plus. So this is the same as this, is the same as this. What happens if I leave them all in there? So what's this going to do now when I run it? I type in a number, it'll add 1 to it, it'll add 1 to it again, it'll add 1 to it again, and it'll multiply it by 2. Let's type in not a number. Ah, that was instant, okay. It's cool. I typed in 1, it was 1, it did all these things to it, became 8, then 22. So if I look back at my slides, basically just the same thing. If we don't have the num plus plus, if we don't have the num plus plus, it'll just go forever. So we want to have something like num plus plus, or something along these lines in our loop so that it changes over time. If num never changes, like if the things relating to this never change, the loop will just go forever. Yes? What does num plus plus mean? I just explained that, man. Pay attention. So num plus plus is the same as saying num equals num plus 1. I'm not actually trying to be mean, it's okay. Cool, and so then the loops have, an overall structure. So we start out by initializing. So for example, if we want to have a number, we sort of initialized it with scanf before, but if we're just doing a loop without any scanf, we need to give it an initial value. So we need to start it by saying int I equals 0, for example. And then we have the condition. And so this is the thing where if this is true, it'll keep going. If it's not true, it'll stop. So for example, while I is less than 10 is the condition. Then we have the statements. So in this case, it just prints out hello, number, whatever. And then finally, we have the update, which is I equals I plus 1, or I plus plus, or I plus equals 1. Cool. Does this make sense? Yes.
We can do that interesting number. So what if you want to stop it less than 10? Because instead of 1, I is less than 10, right?
Yep. I didn't catch the bit at the end. Yeah, it'll continue until num is 10, then it'll stop. All right, so if I had the I++ above the printf, would it stop earlier? So I think I understand your question. I think this is your question. I'll delete those ones, not all of them. So I think the question was, I have in my loop, right, while num is less than 10, print some stuff out. Shh, be quiet, please. While num is less than 10, print some stuff out, and then num equals num plus 1. So the question, I think if I understood it, was if we put this up here, will it stop before it does the printfs? That is a very good question. So let's run this code. So if I enter 8, for example, and I go full screen. So I've scanned an 8. I'm saying, well, number is less than 10, number is 8. 8 is less than 10. So I increase number by 1. Number becomes 9. I print out hello, num is 9, and hello. And then I don't increase it again here. And so then I come around here again. While num is less than 10, well, it's 9 at the moment, so that's less than 10. I increase it by 1 to 10. And then I keep going and print it out. So even though this condition is now false, like when we get to this point here and num becomes 10, even though it has become false, it doesn't check it again until it gets to the very end of the loop. So the stuff inside the loop will always completely execute, and then once all that's done, it'll check it again. Cool, good question. Another question at the back? In here? Do you mean in this bit here? Person asking question. What is your question? I don't understand the question. So if I put a scanf in here and like scanned another number in here. So like if I overwrote the number in num, are you saying? So what will happen here is at this point it'll change what num is to whatever we've typed in again, and then it'll check if this is true. So if we enter 6, for example, it's done the numbers, num plus 1 has made it 7, it's printed out, it's 7, hello. And then we scan a number, whatever number we give it is the number that it becomes. And so then it's running this again, it's making it 5, printing out hello. And if I typed in like 20 here, for example, this would become 20, and then it's not less than 10, so it would stop. So looking back at this license code, right, you can see this over here. We started out by calling our getSpeed function, our getLicenseType function, speed limit function, going too fast, blah, 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 and so on. And so I really wanted to draw a diagram showing this. So you can sort of think of functions as being like pancakes. What do you mean, Andrew? That's crazy. When we call a function, our program starts with our main function, right? Is that viewable? So when we have our main function, we call our main function, and then when our main function calls the getSpeed function, it's sort of like we chuck this getSpeed pancake on top of the main pancake. And then if getSpeed called another function inside it, or does it, calls printf. Printf will also appear on top of this. So it's like we start out at main calls getSpeed, getSpeed calls printf. Printf will then print out the thing, you know, enter the speed, or what speed were you going. And then printf is gone. Then next it calls this scanf function. Scanf. It scans in the speed. Then it is gone. And then this function returns. So it returns its speed back to main. And so if I write up main really fast, I have like, right, when I say in main, in speed, it's like, in the main function here, I've made myself an int. I've made a piece of memory to put the speed into. And then, because I call a function over here, right, because to get the speed, I call the getSpeed function. I don't know yet what number goes in this box. So I have to call into this getSpeed function. We can see in here, it makes its own speed here. And so there was a question about, like, do the names matter within things? Is it going to override it? The answer is no, it's not. So, pick a different color. This one here is like the variable we have inside getSpeed. And even though they're both called speed, you can see they're an entirely separate sort of pancakes, entirely separate bubbles. And so whatever we do to this speed one in here, if we make this be 5, this one in here is going to just stay as nothing for now, right? Because what we're doing inside this getSpeed function doesn't change anything in main. And so then when I getSpeed function, it called printf, it called scanf, it got a number, it got 5, for example. This is going to return 5, right? And so then, because this getSpeed is returned 5, we can effectively write, like, this line is now equivalent to in speed equals 5. And so then the 5 gets, like, copied into here. Does it sort of make sense? We have our black box in speed. We say, hey, please give me a speed. It gives us back a speed. And then that goes into this box here in main. Cool. So what happens if I do something like this? I have code. I'll do it in a new thing. So let's say I have a function like int double, no, triple. Right, and so I have this function called triple. It takes in a number. It goes number equals number times 3, and then returns number. Right, so what does this function here do? Hopefully it's fairly straightforward. You give it a number, it multiplies that number by 3, and then it gives it back. So what will happen if I do this? Put that into A, D, A, triple A. So looking at my main function, I make an int called A, I scan in a value, and then I call the triple function here. Maybe I'll... and then inside this function here, I'm making num be num times 3, right? So I'm tripling this number. Shh, please listen for 4 more minutes. So I have this variable here, A. I scan it and I print it out. I call this triple function. Inside this function, it takes that number in, call it A, just for fun. It makes A be itself times 3, and then returns A. So when I call the function like this, is A going to change? Who thinks A is going to change? Who thinks A is not going to change? Who thinks they're really confused? And then the other, like 70% of you who didn't raise your hands must be asleep. So we're passing in a number to our triple function. That's changing the number, right? We're changing what A is in here. If I say like in triple A is... So we can see in the triple function, what do you mean?
So I don't get the int triple when it's doing int A.
As in, do you think it needs that, or?
I don't know why.
Okay, so when the question was like, what does this int A mean here? So when I have my function triple, I'm saying, hey, the function's called triple. Shh, please be quiet. It takes in an int called A, and so now this function now knows about an int that's called A. And so we can now say things like printf A, because A is a variable that exists in the function that it knows about.
Instead of A, but just put triple instead.
Could I just...
Like if you just didn't do the int A, instead of A, put triple. So if you replace A with triple, it would still work. Like for the...
As in this bit here? So is the question, can I just do like that? So I think I understand the question. The question is saying, like, do I have to use the name A in here? Can I use the name triple? The answer to that is, if we have like this and call it triple, it's going to get confused. To this program, triple is a function. If we try and use the name of the function in the printf, it's going to go, I don't know how to print a function, right? I know how to print ints. So my program, I scan in a number, print out what it is, call the triple function, print out what it is in the triple function, triple it, print out what it is afterwards, and then return. Right, so I'm going to enter in 4. It says here A is 4. It then triples A. In here it's printing out in triple A is 4. It's tripling it, then it's printing out in triple A is 12. So what do you think this printf would say now? We've passed in A, we've given it A, it's tripled A. Is A now going to be 12?